Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the earlier sessions, we were talking about economic time series and various components of time series. As one of the component of time series, we are discussing secular trend, straight line trend computation by freehand method, method of semi-averages, method of least squares and method of moving averages have been discussed. In this session, we are going to talk about non-linear trend. Non-linear trend means a trend which is not a straight line. It may be a curve. So, the simplest example of non-linear trend is a second degree parabola. So, in this session we are going to talk about non-linear trend, and in particular we will be computing a non-linear trend for a second degree parabola by the method of least squares. Also, exponential trend is computed with an example. The simplest example of nonlinear trend is the second degree parabola, the equation of which is written in the form yc, that is computed value is a plus bx plus cx square. As we were discussing in the linear trend, when we have to compute two constants a and b, we have to take the summation of the trend equation as it is, then summation has to be taken after multiplying the equation by x. Here also we will be taking the summation as it is for the first equation and multiplying by x and taking summation, next multiplying by x square and taking summation. Hence, we will get 3 equations. 3 equations solved gives you the values of a, b and c. When numerical values for constants a, b and c have been derived, the trend value for any year may be computed by substituting in the equation the value of x for that particular year. The values of a, b, c can be determined by solving the following 3 normal equations simultaneously. As discussed, first normal equation is obtained by taking the summation as it is with the second degree parabola. Second equation is obtained by taking the summation after multiplying the parabolic equation with x. The third equation is obtained by taking the summation after multiplying the parabolic equation with x square. So, summation y is equal to n a plus b into summation x plus c into summation x square. Then summation x y is equal to a into summation x plus b into summation x square plus c into summation x cube. Then summation x square y is equal to a into summation x square plus b into summation x cube plus c into summation x power 4. We have to solve these 3 normal equations and find the values of a, b and c. Note that as discussed, the things has been given here as text. Okay. When time origin is taken between 2 middle years, then summation x and summation x cube would be 0. In that case, the above 2 equations are reduced to y is equal to n a plus c into summation x square, and summation x y is b into summation x square, and summation x square y is a into summation x square plus c summation x power 4. The second equation gives you the value of b, and then a and c can be solved by first and third equation simultaneously. So, likewise it is computed A is equal to summation y minus c into summation x square by n. This formula of A, B, C has to be used only when summation x and summation x cube is equal to 0. Okay. So, B is equal to summation x y by summation x square and C is n summation x square y minus summation x square into summation y divided by n into summation x power 4 minus summation x square the whole square. Now, after discussing 5 illustrations in computing the secular trend, linear trend by various methods, this is in continuation. Illustration 6 is the price in rupees of a commodity during the year 2005 to 2010 is given below. Fit a parabola y is equal to a plus bx plus cx square to this data. Estimate the price of commodity for the year 2013. So, the values are given from 2005 to 2010, 6 values are given. So, corresponding to the year 2005, 100 rupees is the price of the commodity, and for 2006 is 107, for 2007 is 128, for 2008 is 140, for the year 2009 is 181, and for the year 2010 it is 192. Also plot the actual and trend values on the graph. Solution. To determine the value of A, B, C, we solve the following normal equations. The normal equations are written 1, 2, 3. Now, this is the calculation wherein we have taken the year values. Now, the totals n is equal to 6, summation y is 8, 4, 8 and summation x equal to 3, summation x square is 19, summation x cube is 27, neither is 0 actually, summation x power 4 is 115, summation xy is 771, summation x square y is 3099. Okay. Now, we will substitute these summation values in the normal equations, that is summation y has to be substituted as 848 and summation x has to be substituted as 3, summation x square has to be substituted as 19. Likewise, all the summation values are taken and it is substituted in these 3 equations, then we will get the 3 equations as 848 is equal to 6a plus 3b plus 19c. 771 is equal to 3a plus 19b plus 27c. Third equation gives you 3099 is equal to 19a plus 27b plus 115c. Now, how to solve? These are equations 1, 2, then 3. From 1 and 2, multiplying this equation with 2 and then subtracting, we get the corresponding values as 35b plus 35c is equal to 694. Okay. Similarly, multiply equation 2 by 19 and equation 3 by 3 for this to eliminate a. To eliminate a, multiply equation 2 with 19 and multiply equation 3 with 3 and then subtracting, we get 53.52 is equal to 280b plus 168c. Okay. This is 4th equation and this is 5th equation. Now, after reducing the equation in terms of a, b, c to b and c alone, we can just solve this 4 and 5 and we get the b value and c value. B value comes to be equal to 18.04 and C value comes to be equal to 1.786. Substitute this B value and C value in equation 1, we get A value is equal to, substitute B and C in 1, we get A is equal to 126.68. Okay. What happens? The equation now, therefore, second degree parabola is just substitute the A, B, C values. Second degree parabola is y is equal to 126.68 plus 18.04 x plus 1.786 x square. Okay. This is the second degree parabola. Now, for computing the trend values, we have to substitute their corresponding x value. Corresponding to x is equal to minus 2 for the year 2005, corresponding to x is equal to minus 2, we have to compute the corresponding value as 97.744. We shall see this, that is for the year 2005 x is minus 2 and x square is 4. So, we shall see how this is calculated for the year 2005. X is equal to minus 2, therefore, y at 2005, that is the trend value, is 126.68 plus 18.04 into minus 2 plus 1.786 into minus 2 whole square. This value comes to be equal to 97.744. Okay. Similarly, we calculate the values, that is the 97.744 for the value for the year 2005. Similarly, for the year 2006, we shall calculate the value as 110.426. Okay. Likewise, these values are calculated up to, for the year 2010, the trend value is 196.874. Next, exponential trend. The equation of the exponential curve is of the form y is equal to a into b power x. Putting the equation in logarithmic form, we get to the trend like equation, that is log y is equal to log a, all are natural logarithms to the base e plus x into log b. When plotted on a semi-logarithmic graph, the curve gives a straight line. However, on an arithmetic chart, the curve gives a non-linear trend. In order to find out the values of a and b, the two normal equations to be solved are, after taking logarithms, you just take the summation of the equation as it is, then multiply that logarithmic equation with x and then take summation. Then we will get two normal equations. Two normal equations are solved for a and b and then substituted in y is equal to a into b power x. You should not substitute in logarithm. Logarithm has been taken for calculating the a and b values. So, when deviations are taken from middle year, that is obvious summation x is equal to 0, the above two equations take the form summation log y is equal to n into log a. So, log a is summation log y by n and log b is obtained from this equation as summation x into log y by summation x square, taking the antilog of this expression to arrive at the actual trend values. Now, this example is an illustration for calculating the exponential trend values. The sales of a company in lakhs of rupees for the year 2004 to 2010 are given below. Years is from 2004, 2005, 6, 7, 8, 9, 10. Sales is 32, 47, 65, 92, 132, 190 and 275. The question is estimate the sales figures for the year 2013 using the equation of the form y is equal to a into b power x, where x is equal to years and y is equal to sales. So, the solution goes like this. First of all, take the year and number of values given is 7 and sales values are represented as y 32 to 275 and summation y is 833. Deviations taken from the middle year is 2007, therefore, deviations taken from the middle year 2007 that is 2007 is kept as origin, 2004 minus 2007 is minus 3, minus 2, minus 1, 0, 1, 2, 3, summation x is equal to 0, then summation x square is equal to 28, and then taking natural logarithms, that is log to the base e, log of 32 to the base e is 1.5051 corresponding to y value, then log of 47 is 1.6721, and then log of 65 is 1.8129. Then x into log y, x value is minus 3, so minus 3 into 1.5051 is minus 4.5153, then minus 2 into 1.6721 is minus 3.3442. Like that x log y is calculated, and then their summations are written here. Summation x square is 28, summation log y is this total 13.7926, and summation x into log y is minus 4.3237. So, after calculating the respective summation values, we have to compute a and b value now. So, for fitting the equation y is equal to a into b power x, taking logarithm log y is equal to log a plus x into log b. Since the summation x is 0, we use the direct equations, that is log a is equal to summation log y by capital N, that is 13.7926 divided by 7, and this value is 1.97. Okay. And similarly log b is equal to summation x log y by summation x square. What is x log y? Summation x log y is 4.3237. Summation x log y is 4.3237 and summation x square is 28. So, 4.3237 divided by 28 is equal to 0.1544. Substitute this in this log a and log y is substituted in this equation log y. So, log y is equal to log a is 1.97 plus 0.1544 x. Okay. And the question is we have to find the sales figure for the year 2013. Okay. When the year is 2013, because the origin is taken as 2007, x value will be 2013 minus 2007, which is equal to 6. Therefore, log y is equal to 1.97. Substitute x is equal to 6 here. 1.97 plus 0.1544 into 6. This value is 2.8964. This is log y. So, y is equal to antilog of 2.8964 and this value is 787.77. So, y value for the year 2013 is 787.77. Conversion of annual trend values to monthly trend values. Usually for trend computation, annual figures are employed. However, it is sometimes required to obtain monthly trend ordinates. In converting straight line trends from an annual to a monthly basis, two situations must be clearly distinguished. That is, for series such as sales, production or earnings, the annual figure is the total of monthly figures. Here it is necessary to divide both A and B by 12, so that we get it for monthly to reduce them to monthly level. In other words, on the average, monthly sales or production is 1/12 of the annual total. The B values must then be divided by 12 once again in order to convert from annual to monthly increments. So, the necessity of dividing b twice by 12, that is by 144 altogether, must be clearly understood. One time division by 12 is for conversion from annual to monthly, and another time division by 12 is for the monthly increment. So, the division of annual change by 12 gives only the change from the same month in a given year to the corresponding month in the following year, or the annual change in monthly magnitudes. However, we are here seeking for an expression of the change in each and every month. So, that is monthly change in monthly magnitude. That is why B must be divided by 144, that is, it has to be divided by 12 two times, again by 12. In conclusion, to convert an annual trend equation to a monthly basis, when the original data are given as totals, A is divided by 12 and B is divided by 144. If x in the trend line equation represent only 6 months, it is to be divided by 72 instead of 144. This particular illustration gives you how the annual trend equation is converted to monthly trend equation. Convert the annual trend equation for tea production in India to a monthly trend equation, that is y is equal to 108 plus 1.58 into x. Origin given is 2010, that is time unit is 1 year, y is tea production in million kilograms. Solution: monthly trend equation will be obtained by dividing A by 12 and B by 144. Thus, monthly trend equation will be y is equal to 108 by 12, that is A value is divided by 12 and B value is 1.58 divided by 144 into x. Y is equal to A plus Bx. A is divided by 12 and B is divided by 144. Origin is July 1, 2010. Time unit is 1 month and Y is the monthly production million kilograms. Next, selecting the type of trend. We have discussed different ways of fitting trends. Fitting a straight line trend by freehand or graphical method, method of semi averages, method of least squares, method of moving averages, also nonlinear trend method, method of least squares wherein a second degree parabola has been fit, and method of least squares for exponential trend has been discussed. However, it is not all, some other equations might also be reasonably used. Even though each series presents its own individual problem, most series can be handled by the methods which we have described. Of course, what we try to do in any particular case is to select that equation or that method of measuring trend which best describes the gradual and consistent pattern of growth. The choice of a particular type of equation that best describes is often difficult and needs considerable amount of judgment and experience. While deciding the type of trend, the first step consists of plotting the data on arithmetic paper. If the trend is not linear but either concave upwards or concave downwards, the data should be plotted on a semi-logarithmic paper instead of arithmetic paper. Examination of the plotted data often provides an adequate basis for deciding upon the type of trend we use. When further guidance is needed, approximate trend may be drawn by inspection and the following tests applied to the smoothed curve. If the first difference tend to be constant, use a straight line. If the second difference tend to be constant, a second degree parabola, second degree curve has to be used. If the approximate trend when plotted on arithmetic paper is a straight line, use straight line. If the first difference of the logarithms are constant, fit a second degree curve to the logarithms. If the second difference of the logarithms are constant, fit a second degree curve to the logarithms. If the first difference tend to decrease by a constant percentage, use a modified exponential. If the first differences resemble a skewed frequency curve, use a Gompertz curve or a more complex logistic curve, which is out of the scope of this subject. In this session, discussion about nonlinear trend is done. Calculation of nonlinear trend, that is the simplest example is second degree parabola, is discussed with an illustration, and also computation of future value using exponential trend has also been discussed. Fit a second degree parabola for the following data. The year starting from 2006 to 2010, whereas the units produced Y values are given as 70, 72, 88, 80 and then 90. Also one more question may be posed, fit an exponential trend for the following data. Year has been given from 2005 to 2010 and the production is given in metric tons, that is 64, 70, 75, 82, 88 and then 95. Thank you.